This is Food Chemistry Unit 1, Chapter 2, Scientific Evaluation Being Objective. Food science is an applied science. The scientific knowledge is put to practical use. So we use knowledge from previous science courses and practical applications. So these are concepts from biology, chemistry, physics, nutrition, etc. They can all be applied to the production, processing, and packing of the food supply. So all science courses use the scientific method, which is the system of steps to solve problems. So you've probably seen these in your other courses, especially if they were taught by me. This never changes. So the scientific method begins with observations, then there's a hypothesis, which is your educated guess. There's the experiments, the data that you collect from the experiments, the analysis of that data, and then the conclusion. Never changes. Now, our experiments will use lab safety. Again, you've seen that in your other courses, will not change. You will need to understand your equipment, understand your measurements, and then we'll review the SI units. So if you remember, the SI is the metric system, the International System of Units. So the scientific community uses metrics because scientists working all over the world share information. But for our labs, hey, we will use the US measurements from most of them because most of your equipment will actually be measuring cups and spoons which have the US measurements on them. So if you really want to use the metric system, just let me know. But most of our labs will use the actual English US measurements. So let's just take a look though at our equipment. Here are the measurements that we're going to look at in this course. Here's the equipment and here's the units. All right, so if we're measuring mass, we will use scales, and this will stick to the metric system. Our scales will measure in grams, so you will see a G on there, okay? For length, we don't measure length too much, but when we do, it would be with a ruler or a meter stick. And there's the meter again, that is the metric system, meter, centimeter, and millimeter. So mass we do use a lot, length not so much, maybe 1 or 2 labs. All right, now for volume. Okay, for volume, if you're finding the volume of a liquid, you will use that graduated cylinder. And you read the bottom of it, which is called the meniscus. It's like that little dip in the liquid. And that is the liter or the milliliter. And we do have like liter bottles and such like that you'll draw some food ingredients from, so that's not a big deal. Okay, now if you have to find the volume of a solid, which we will do for something like a Skittle or an M&M, that's something irregular, right? So you wouldn't use a ruler for that. You could use the ruler for like a solid if you took chemistry or physical science, you measured like little blocks and such, and you would take length times width times height. That's where this centimeters cube is coming from. But if it's an irregularly shaped object like an M&M or a Skittle, you'd use water displacement, and we will use that. So that would be the milliliter again. Time, it'd be a clock or a stopwatch, and we will actually need this. We're cooking certain things, so that'd be the second. And then we'll do temperature a lot, right? So you'll either use a thermometer or a LabQuest, and that will be in Celsius. But a lot of times, if you're using measuring cups and such for volume, that will be the English system. But we'll talk about that when we do the actual labs. Okay, so there is a need to convert. So I kind of have a little mixture here of converting between metrics and non-metrics. So you will actually have to do this for some of the labs. So this is just a little refresher here on how to convert between units. So I'm going to show you the scientific way, especially at chemistry or physical science. This is what we teach you. But if you can figure these out, let me get this up here. There you go. My ink was not working. If you can figure these out doing your own method, that's fine. But this is how we do train you in science. So if you look at this first one, it says how many grams are in a milligram. So in one, gosh, that is ugly. Like that. Get that out of here. There we go. So in 1 milligram, We use what's called factor labeling or converting. In my class, we always use the t-squares, and you really have to use this conversion factor right here to change it. So it would be 1,000 milligrams in 1 gram. So you have the factor. Why did the milligram come down here? Because you want it to cancel. And if your numbers are top to bottom, you divide. So if you have a calculator, the top is just 1, and you would divide it by 1,000 and see what you get. So 1 divided by 1,000 is 0.001, and that's gram. So there might be a lab or two where you might have to do this. I wanted to refresh this. But here are these units that you're probably used to with like the food that you have in your house, right? Cup and gallon, right? When you buy milk it's usually in a gallon, and when you follow recipes it's asking for cups and things like that. So we are going to use this English system quite a bit because that's just the nature of our equipment. So check out this one. How many cups are in a gallon? So you would start with a gallon. And I gave you a bunch of these little conversion factors, and you basically find the ones that have the unit that you're on and go from there. So if we're in gallon, it's right here. In 1 gallon, you have 4 quarts. So gallon goes on the bottom. You're trying to get rid of it. And 4 quarts goes on top. You never hear quart in a chemistry class, right? All right, next, I didn't ask for quarts, though. I asked for cups. So you got to find the conversion factor that uses the quart. It's right here, cup to pint. So in 1 quart, 2 pints. Pint we don't use too much, but I just threw it in because you may have something in your house that has a pint or needs it. We'll see. So I didn't ask for pint, I asked for cup, and that is more common. So it's right here. 1 pint is 2 cups. So pint is out. And now you've got a bunch of numbers here. So first of all, you have all ones on the bottom, so you can just ignore that. But what do you do with these numbers on the top? You multiply. So it's 1 times 4, which is 4. 4 times 2 is 8, and 8 times 2 is 16. So there's 16 cups in a gallon. Or you could have put that into your calculator as well. Okay, let's try one more. And this is probably more close to what you'd be looking at here. It's these ounces and tablespoons. Yeah, because a lot of our equipment uses tablespoons, things like that. So just using the factors that I gave you, if you have 5 tablespoons, you can also use TBS for tablespoon. You're going to see that a lot in this class. So if you have 5 of these, how many ounces is that? So again, I gave you the conversion factors in parentheses. Use the one that has tablespoon first because you have to get rid of it. So in 1 tablespoon, 24.3 grams. And this does happen. Sometimes you have to go between gram and things like that, which is a metric unit. So tablespoon is out. And I didn't ask for gram, I asked for ounces. So it's right here. 30 grams is in 1 ounce. So you want the gram to be out. And then, isn't this funny? Ounce goes to OZ. All right. And now to solve this. Okay, now you have numbers on the top and the bottom. So how do you figure this out? So let's work on the top first. If you're going across, you multiply. So this would be 5 times 24.3 times 1. And I get 121.5. But you can't ignore the bottom, right? So this is 1 times 30, which is just 30. So you divide by 30, and let's see what you get. 4.05. And that's ounces. And I'm sure the OZ is a language thing, but it's just funky how things change like that, right? And those of you that took chemistry, you do not have to worry about significant figures in food chemistry. You're welcome.